Hello everyone, welcome to my YouTube channel Psychology Class for All. Today we will try to understand standard deviation in psychology, understanding how people vary. You gave a psychology test to your class. The average score was 50, but some scored 30 and others 70. So, is the average telling the full story? No. Standard deviation gives us the real picture. Let's learn how. Here is the image comparing two datasets. Dataset 1 that has low spread, that is in blue color, has values tightly clustered around its mean, that is 50, leading to a narrow distribution. Dataset B that has got high spread, and that is in orange color or red color, has the same mean, that is 50, but values are more disparate, creating a wider spread. This illustrates how two data sets can have the same central tendency, mean, but very different variability. So standard deviation is a measure of how spread out the values are from the mean. It tells us the typical distance a score is having from the average. Standard deviation calculation from ungrouped data. So there is a formula. Standard deviation is equal to under square root summation deviated x square divided by n, where x stands for deviation of scores from its mean, n stands for the total number of score. Here is an example of calculation of standard deviation from ungrouped data. Step 1 is mean calculation. So we have got raw scores like 6, 8, 10, 12 and 14 and the total is 50. So the first step is mean calculation, that is 50 divided by 5, 10. Step 2 is finding deviations from the mean. So finding deviation, that means x minus m. That means each value will get subtracted by its mean, and now the numbers are reflected in second column. And then third step is to square the deviations, and the fourth step is SD calculation, standard deviation calculation. So after placing all the values as per the formula given, the total outcome is 2.68. On average, each score deviates by about 2.68 units from its mean. If SD is small, standard deviation is small, scores are clustered near its mean. But when SD is large, then scores are widely spread. So this is how it should get interpreted. Now standard deviation calculation from group data. Now we have two type of formulas. One is called long method and the other one is called short method. So when dealing with group data, we use either the short method, that is based upon the assumed mean method, or the long method, that is the direct method. Both yield the same result but different in approach. So first we'll learn with calculation of SD with long method from group data. Here is the formula. We'll see the formula of both the methods right now. So this is the formula of long method. SD, the same thing we have done for ungrouped data, but here deviated x will be multiplied with its frequencies. Here x stands for deviation of scores from its mean, f stands for frequency, fx stands for the multiplication of frequency and deviated small x, and then n stands for the scores. Now the formula for short method from group data. Here the formula is I multiplied by summation fx deviation square divided by n minus c square. where I stands for the size of class interval, small x stands for the deviation of scores from its mean, f stands for frequency, fx stands for multiplication of frequency and deviated small x, n stands for total number of scores, c stands for correction, and the formula for c is summation fx divided by n, deviated x. Here fx is deviated x. Now calculation of standard deviation with long method from group data. Here is an example table of calculation and these are the steps. The step 1 is mean calculation. So based upon the class interval, frequency and midpoint, the mean will be calculated by the definition by the formula as summation fx divided by n, and the mean is 24. Step 2 is find deviations from mean. Step 3 is square the deviations. Step 4 is multiply the deviation from frequency with its frequency. Step 5 is calculation of standard deviation as per the given formula, and the result is 6.98. Now we will calculate the same data with short method from group data. So this is the table of calculation, and now this is the step. First step is correction calculation. So for correction calculation, what we have to do, we'll be getting in a question like class interval, frequency and midpoint. These three columns will be written in the examination or in the question part, and then put we need to create the fourth column straightforward by finding the mid class interval, labeling as 0, and the upper class interval will be labeled as -1, -2, -3, and the lower class interval, that means lower than the middle class interval, it will be labeled as +1, +2 and +3, and so on. So the fifth column will be the frequency, the multiplication of frequency and deviated x, that is 3 into -1, and the last column would be will be the multiplication of column 4 and column 5. So for correction we'll be taking the fourth column divided by n. So -1 divided by total 10. So now the result is minus 0.1, and step 2 is calculation of standard deviation, because we are working with the concept of assumed mean formula. So the middle class interval is middle class interval is the place where we are assuming the assumed mean is there. So based upon that formula, this calculation is much easier. So we'll be putting all the values according to the formula, and we'll be getting the result like 6. So when we were calculating standard deviation from long method, it was 6.92, and here it is coming 6. So almost both the values are almost same. So far we have learned calculation of standard deviation from group data with long and short, both the methods. So these two methods differs in few grounds actually. Based upon the mean used, long method actually works with the actual mean. There is a actual mean calculation used to take place, where in short method we assume the mean by thinking that the middle class interval is having assumed mean. About the computation, the long method is much longer and having more steps, and in short method this is quicker with the smaller numbers. Long method is suitable for small and simple data sets, whereas short method is suitable for large or complex data sets. When we are dealing with a number of 100 or 200 or 500 scores, then we can easily use the long method. But when we are dealing with the scores like in thousands and lakhs, then we should prefer this short method, because assuming mean make creates or makes the calculation much simpler and easier. Accuracy. Now, when we talk about the accuracy of the calculation or accuracy of the standard deviation calculation, then longer method is having high accuracy, and the small, or you can say small or short method, has equally high, not exactly, but it's equally high. As we can see, the long method has got the output or SD at 6.92, and short method has got the output or SD as 6. um, Longer method is much tedious, and short method is easier with group data. Why SD is important in psychology? Because psychology is full of individual differences. Standard deviation helps us to understand how consistent or variable these responses are. Standard deviation can be used in IQ tests because SD shows if a group is tightly or widely spread in terms of IQ. In therapy outcomes, SD helps to assess consistency in treatment. In attitude or personality scales, like SD reveals diversity in opinion. For example, two therapy groups have same average stress score, but one has higher SD, that is less consistent result. Now about comparison of SD with other measures of spread starting from range or QD. So range uses or range is for quick access, and range never considers all the values. Range is common in psychology, just to give a rough estimation about the data, whereas IQR or QD is resistant to outliers. It gives middle 50%, and yes, in non-parametric tests this is common in psychology. Whereas the standard deviation gives a complete picture, or gives the complete picture of the data and the variations, and it considers all the values, whether it has got outliers or the correct data. This is most common in psychology. So the standard deviation is more than just math. It's a psychological tool that helps us in understanding how people think, behave, and vary from each other. So, ready to calculate SD in your own data? Try it out and tell us your SD in the comments. Like, share, and subscribe for more psychology statistics magic. Thank you.